That was the last one.
Okay.
Don't tell me the answer.
Shh, Wally. Master of maturity over here. Do you have my report card? I use Spark Screen.
No, she didn't.
All right, let's go over it super quick. Actually, we're not going to go over it. The answer is 296. If you have questions, if you didn't get that, lean, check your partner. Okay, folks, let's finish up. I want to get down to Mr. Van Houten. We need to finish something together. So, let's go. So, go back to your notebooks. Leave the other sheet aside for a second. We're going to come back to it in a second. We're going to learn quickly about how to use trapezoids instead of straight up bars, straight up rectangles for the area of the under these curves. Yeah. I know, it seems crazy at first, but we'll see in a second, okay? So first of all, instead of using our bars or rectangles like we've been using up to now, we're going to rock trapezoids instead. Okay? All right, shh, guys. Too much chatter. Is this a trapezoid?
Yes.
And somebody who is like a master of geometry, without talking, raise their hand and actually tell me how a trapezoid is defined. Maishka?
Polynomial.
No. Yes.
I meant a polygon.
Yes, you can talk.
What? It's basically a quadrilateral with one pair of parallel sides.
That's beautiful. Quadrilateral is a four-sided thing, okay? And it has one set of parallel sides, okay? So this is a trapezoid because it has one parallel set of sides. That makes sense?
Yes.
Okay. Does anybody know the equation for the area? Guys, you got to stop talking. Does anybody know the equation for the area besides Wilmy? Yeah.
So base 1
Yep.
plus base 2
Yep.
over 2
Right.
times height.
Exactly. I've used different letters for it, but it's the same idea. And I use width instead of base. That's fine. The width of the bottom guy and the width of the top guy, you add them together and multiply by the height. And then instead of putting them over 2, I have a 1 half out front. Okay? So that's for a trapezoid, as they say in Spanish. En general.
In general.
Okay. However, let's think about Wilmeen's definition of what a trapezoid is. A trapezoid is a quadrilateral that means it has four sides, that has one set of parallel sides, right? So, true or false? This is a trapezoid. Raise your hand if you think it's false.
Oh.
Raise your hand if you think that is a trapezoid.
You're wrong.
You're right, that is a trapezoid. Okay? It's a four-sided figure, right? And it has one set of parallel lines, so it's
It
a
has
trapezoid.
2.
Where's the other one?
Oh, wait.
All right. It's all right. So, we can actually use the same, if you actually imagine this trapezoid flipped up on its side and this side flattened, it's the same formula. I'm just going to change the letters around a little bit, but the letters don't mean anything, right? That's just made up by humans. So we can take this side and this side, oh, it's kind of a little bit off, but it should be, you see what I'm trying to say. If you add those together and put the 1/2 out front and multiply by this, that's another way to say the area of that trapezoid is this length times the average of these two. This one plus this one over 2.
Are those equations the same thing?
They're the same, I'm just using different letters and I've changed the orientation of the trapezoid. Does it make sense enough to you?
Yes.
If you're going to write one of them down, it's this one. Because that's the one we're going to be using. It is the same thing. It doesn't matter to me, but if you're going to write one of them down, like I said, you should write that one. I'm slacking. Okay, I'm going to give you 15 seconds to finish that, and then I got to get out of here.
Yeah, you do.
Right, shh. So So now this is where it gets cool. This is why a trapezoid is really helpful to us, is because you can imagine how using these instead of the regular old bars that we were using before might give us a better approximation of the function. Let's look. So you're going to write this example, and this is the last thing I'm going to put in your notebook. Use a trapezoidal sum to approximate the area under y equals x squared plus 2 from 0 to 2 when n equals 4. Write that. Hurry. I got to get out of here. Yeah, but it's fine. It's just grading downstairs. All right. Okay, so this is where it gets cool. Here's a picture of the graph of x squared plus 2, right? It's just a parabola shifted up 2, so we have that plus 2. And we're going from 0 to 2 with n is 4. So, all right, math wizards, what's the width of each of these subintervals? Right, 2 minus 0 and 4 and 1 half. 2 right, if you take 0 to 2 and split up into 4 even spaces, each one is 1/2 wide, right? So what's cool about trapezoids is instead of using a regular bar, 0 to 0.5, and choosing the left, middle, or right side as the height of the bar, I can actually use the left and right side for the heights of either side of the trapezoid, right? Like this. So can you see it?
Yeah.
The trapezoid doesn't have a flat top like the bar does. It has an angled top. And this height on this side is the function's value on that side. And this height on this side is the function's value on this side. Does that make sense?
Yeah.
Do it. Yeah. Hang on. Shh. Let's let Livy ask the question so I can answer it. Yeah.
So when you're doing trapezoidal sum,
Uh-huh.
it doesn't matter, like, don't say like the left trapezoidal.
Right, it doesn't matter. You use both sides.
But you always just assume that the shorter height is on the left.
No. That's a great question. Livy just said, do you always assume the shorter height is on the left? No. The trapezoid can also be shaped as, well, we won't see in this example. Can be this is a trapezoid, right, like we've been seeing. But so is this. Okay? So what matters is just that you can think of the corners on the top of this trapezoid are always pinned to the function. If the function looked like this, then my trapezoid would say right here. Okay, it would look like this. It would meet here, and it would come across like that. See what I mean? So it always meets the function on both sides. That's the advantage.
So the two heights have to reach the graph.
Exactly. They're always pinned to where the graph is at. All right. So the next one, right? It starts right here on this side, and then on the other side, it should be at the 1 point, like this. Right? And so you can start to see how it's a much better approximation. It's not always better, but it's often better. Confused? All right, we're going to talk about how we do it in a second. Each one of these bars, right, instead of having just a flat top, it has two heights. One is the left side of the bar of the trapezoid. One is the right side, and it gets its values from the function's height on either side. So if I had these two subintervals, I'm such a bad artist, it's not even worth trying. So the point is, this trapezoid has its left side height is f of 0, and its right side height is f of 0.5, right? Because it has two heights. One for the left side and one for the right side.
Yeah.
Can you feel me?
Yeah.
Okay, so let's go through our steps like we were doing for the other ones. Okay, we have 4 different things. Oh, here's my intervals like I used to write, right? We have 4 different, all right, so write all that, right? Get those intervals in there if you like to do that. And then write the equation for the area. It's worth your time to write this equation a few times in the beginnings before, so you have it ingrained in your little heads. The top right. You just wrote it, but you should write it again. Okay? And now we have to find the area of A, B, C, and D, just like we did before. Okay? The difference is we're not going to use the basic equation base times height like we did before. Instead, we're going to use this trapezoid equation. It's got 2 heights, which means it's going to have 2 function values, one on the left side and the one on the right side, as opposed to one or the other.
So we have to plug it into the equation twice, just for one.
Exactly, yeah. But there's overlap, right? So the right side of A is also the left side of B. So if you keep track, you only have to do it one extra time. Okay, so we have our 1/2. That's going to be in all of them. The base for all of them in this case is the same. What is it?
0.5.
Right, they're all 0.5 wide. So all of these are going to be 1/2 times 0.5 for the left side of the equation. Then we just have to do our heights.
Wait, what do you put on the left side?
We do both sides.
Have we done any sides yet?
No.
Oh.
That was just the base. The B is 0.5, and there's there's 1/2 for all of them because there's already 1/2, and the B is 0.5 all the way down as well. You got me? Can you feel me?
Yeah.
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 What do you do if the intervals aren't consistent?
Same thing. Right? These numbers can change or whatever. Okay. You always just use the function's value on the left side and the right side. I think your one on the practice classwork in a second is going to be like that, so you can get a practice on that.
Does it matter which one? H1 or H2 is left or right?
No. Okay. Ready? So let's talk about the first one. What's my H1 on the left side here? F of what?
0.
0, right? Which happens to be 2. I heard somebody start to say 2. And F of 0.5 is my one on that side. Does that make sense?
Yeah.
And then the next bar over here, whoops, I got F of 0.5 on the left side. I got F of 1 on the right. So that one's like that. And this one's F of 1 and F of 1.5. Whoa, where's my mouse going? 1.5 over here, right? Because here's 1.5. So F of 1.5 is this height. And F of 1 is this height. So we add those together. Yep. So one thing that's nice about this is you have F of 1 twice. So just keep track of it, and you don't have to punch in your calculator twice. Right? Does it make sense?
Yeah.
Yes.
Okay. Punch that on all your calculators and get your answers.
I get it.
Check that answer. Make sure it's right.
It is right.
All right. Cool. When you're done doing this, actually do it. I want you to have an experience in putting those numbers in your calculator and getting the answer out. Then you can start number 2 on here, which has weird subintervals. Okay? I'll check the answer on this real quick, and then I gotta go. You can
I can handle calculus.
It's 43 for number 2. Look at you.
Wait, what?
No, I'm gonna finish that. Yeah. Freeze that. No problem. Peace. All that whole lecture and all the sheets and stuff over the break, MrCaden.com.